For lesson 1.1, what is a linear function? Our goal is to practice creating tables and solving some linear functions. This is related to our Unit 1 goal of understanding the relationship between slope and area through distance and velocity. The reason being that linear functions are the simplest form of graph to explore the concept of slope and area. Okay, to start, just some definitions. First off, we're going to be looking at a lot of power functions for the first few units, which are any term or group of terms of the form ax to the n. So it's a variable with a coefficient and power. In this case, we are looking at linear functions, which are power functions that have a first degree variable and can potentially possess a constant. They will often be written in one of these two forms. Slope-intercept form, which is y equals mx plus b, where the m is the a in the top example, and the x has a first power, so n would be 1. X is your input, y is your output, m is your slope, and b is your y-intercept. There's also point slope form that we'll be looking at, where we have y equals m times x minus x1 plus y1. That x1 and y1 is representing any point on the line, just any single coordinate. For this assignment, you'll be asked to do two different things with these linear functions just to get re-familiarized with how they work, which is fill out a table of values for these following functions and solve the following linear equations for x. For all the tables, you'll probably notice there's a point already put in here. A lot of the times we're doing that to indicate that this is the y-intercept, and it's kind of like you can always put this where x equals 0. So just to reinforce that fact, we've got this here. But if I want to fill in the other spots here, I just need to replace the x here with any of these values in parentheses, use that value to multiply the slope, which is -5 in this position, and then add the y-intercept, which is the 20 that we just mentioned. So let's look at some examples here. I could start by doing y equals -5 times 1 plus 20. That would be -5 plus 20, or -15, or positive 15 rather. For 2, we would have y equals -5 times 2 plus 20. That would be -10 plus 20, or positive 10. And you could continue this pattern. -5 times 3 is -15, plus 20 is 5. And -5 times 4 is -20, plus 20 is 0. So we just want to do that for each of the tables to get them all filled out. Over here for our solve equations, we only really have a few steps because there's only so many things that you can do with a linear function. The first thing you want to do in these situations is subtract the y value or the y-intercept. Whatever you have sitting out here in these equations, you always want to make sure as your first step to subtract that value from both sides. Once this is complete, the next thing we want to do is we want to divide the value that we have on the left side by the slope. So once we get the subtraction here, 11 minus 3 is going to give us 8. We're going to want to take that number and divide it by the -2 that we have sitting here. Same situation down here. We get 13 minus 1 is 12, and we'll want to divide that 12 by the 2 that we have here, the slope. For the last step then, this will give us 8 divided by -2, which is -4. And for this linear equation down here, we'll get 12 divided by 2 equals 6. Now notice with a slope-intercept equation, you're done once you've done step 2, dividing by the slope. You might notice though, with the point slope form, we would still have this entire parenthesis set that we have here. This would be freed now. We wouldn't have the parentheses anymore because we've divided off the thing that was multiplying it. So now we want to subtract our x value that we have over here, the point slope form only. If we subtract a negative, that's the same as adding it. So I'm actually going to do plus that right there. And ultimately we solve for x, the value is -3. So those are the two things that we're going to be asking you to do with this assignment. Let's head over to Desmos and see how they work over there. So our Desmos file here says, create tables for functions by typing in your function below, then clicking the gear icon above this note, this one right here, then choosing convert to table. You can click the circle to the right of the equation to toggle the graph line on and off and edit and add as many points to the table as you wish. So let's try with the one that we had our table for in the assignment, which was -5x plus 20. So we'll type that in. We can see the graph forms over here. If we want to turn the graph on and off, we can do that. The main thing we want to do is go over here and click create table. And this will give us all of the values that we're looking for. Of course, for ours, it started at 0 and it went 4. So we can just edit this first one to 0 and hit our down arrows for 1, 2, 3, and 4. And you can see it automatically gives you the y values you want. Well, And again, you can turn these points on and off for these two things. It turns out that Desmos can also solve equations in sort of a unique way. Here's just an example of one of these equations, 5 equals 2x plus 1, and we want to solve for x. If you just type this equation in the way that it is and you allow the graph to activate, it will create a single vertical line. And that vertical line will have the exact same x value no matter where you drag your mouse around. In this case, that x value is 2. That 2 is the solution to this problem. If you were to plug 2 in for x, 2 times 2 is 4, plus 1 is 5. In general, this should work for a lot of our solving, and if a problem is really mechanically hard to solve by hand, this might be a good way to just get to this quickly. So that's what we're working out for this first assignment. Next assignment, we'll be looking at slope. Thank you very much. See you soon.